Hello, so we are going to look at Pythagoras. Here's how to do Pythagoras' theorem and a few of the things associated with it. So Pythagoras is a rule that only works with right-angled triangles. So why on earth would we need this? So here's my sort of example. Why use Pythagoras? It's great for building. So if you know this length of 5 foot and you know this length of 12 foot, you would then know what length the side of the roof needs to be. In every right-angled triangle, we have the longest side, and we've learned that that is called the hypotenuse. So let's have a little look at an example. If this was 3.5 and this is 4.2, I can use Pythagoras' theorem to find out this missing length. We call this, remember, the hypotenuse. You are going to need your calculator, so make sure you've got your calculator. If you haven't, pause the video and go and get one. We are going to be using these buttons, the squared button and the square root button. On the newer style calculator, we've got squared here, we've got square root there. Here's a triangle, and I have written all of the sides on it, 3, 4, and 5. I want to try and explain to you how Pythagoras works. If I've got 3 here and I square it, I get 9. If I have 4 here and I square it, I get 16. What happens if you add up the squares of the 2 straight sides like these? 16 add 9 is 25. And look what happens. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 25 here. So the rule that we can get from here is that if this is called A, this is the side. If I do A squared, like 9, and I do B squared, which is 16, and I add B squared, it equals this hypotenuse here squared. It equals the hypotenuse squared. In lots of revision books, people will call this side C. So A squared, if you've seen it, plus B squared equals C squared. When they talk about C, they mean the longest side. So how does this work? Let's try it again. A, B, and hypotenuse. It simply means that you type in 6 squared, like A squared, plus B squared is 8 squared. Right, and I type that in. And if I add these two up, I get 100. 100 is the same as 10 squared. A squared plus B squared is hypotenuse squared. So if you haven't, I want you to write this formula down. A squared plus B squared is hypotenuse squared. How do we do at Pythagoras? We try to find out what the length is. So I'm told this one's 5 and 12. So what is that length? So let's have a little look. I know A squared plus B squared equals hypotenuse squared. So underneath, I'm going to write 12 squared, add, this can be my B, 5 squared. It equals the hypotenuse squared. So if I'm going to type that in, 12 squared in your calculator, add 5 squared equals 169. Now think in real life. If this is 12 and that is 5, that cannot be 169. It'd be way too big. This is my hypotenuse squared. So you have to realize to do the opposite, you have to square root your answer. And I want you to find your answer button on your calculator to do that. If we look up here, the answer button on the old calculator is here and the newer calculator is here. So find your answer button. we're going to type in square root of your answer from before. You can type in square root 169 if you want, and the answer is 13. So this side here is 13. Let's have another go. You have a right-angled triangle. We know the formula, a squared plus b squared equals, sometimes people say c, or we say the hypotenuse squared. So we've got 3 squared, add 4 squared, equals. 3 squared, I'm typing it in now on my calculator, so should you, add 4 squared, is 25. So to get just the hypotenuse, and not the hypotenuse squared, I need to square root my answer from before. Or, yes, it's square root of 25, and the answer is 5. So what is this length? 5 cm. So you need to do 3 squared plus 4 squared equals square root your answer. And I want you to have a go at these 4 questions for me. A squared plus b squared equals square root, and you will find the missing lengths. Pause the video and have a go. Here are your answers: 41, 29, 25, and 39. That's the first part of solving problems with Pythagoras' theorem. Now have a look at this one now. What is the same and what is different? They've both got a 5 and a 13. But this is the kind of question that we've already looked at, with an A and a B and a hypotenuse. The hypotenuse is the one that's missing. Look at this question here. I've got an A, but that's missing a B, and I know the hypotenuse. So I'm going to have to use what we call a takeaway version. I'm going to show you what that means on the next slide. Let's write out the formula. A squared plus b squared equals hypotenuse squared. So if I write them in, I don't know a, so I'm writing a squared plus 5, because that's b, 5 squared, and that is going to equal 13 squared. Right, equals always goes under equals. We know about solving equations, and if they have added 5, we need to take away 5 squared. So take away 5 squared, I'm going to get 13 squared. So I've just typed in that 13 squared, and I take away the other side squared. Take away 5 squared, and that leaves me with a squared. So all I've done is kind of put that to the other side. So this is what I meant by the takeaway version. Hypotenuse squared this time, take away 5 squared. And that will give me an a squared of 144. So if I know what a squared is, I need what a is, so I have to square root the answer from before, and the answer is going to be 12. So my missing length equals 12. Let's do one more example quickly. So I know the hypotenuse. So I'm going to call this one A, I'm going to call this one B, and this is my hypotenuse. So A squared plus B squared equals hypotenuse squared. A squared, don't know it, plus 11 squared is equal to 18 squared. So I have to use the takeaway version because they've added 11 squared. I have to do my equation where I take away 11 squared. This is going to be a bit trickier. So I'm going to have to type this in. Can you type this in as well, please? 18 squared, take away 11 squared equals, so a squared is 203. Now, don't get rid of this. You just need to press square root and your answer button. So find that square root answer. Sometimes you need to press the SD button. A equals 14.2478, and it will keep going a few different more numbers. 1 decimal place. So let's have a little look. 1 decimal place. Look next door. Does the 4 keep it as a 2 or round it up? It keeps it. So A is 14.2. And that's it. So what have we learned? We have learned, and this is worth jotting down, if you know the A and the B, you have to use an adversion, which means A squared plus B squared equals the hypotenuse squared. If you already know the hypotenuse, we actually end up doing hypotenuse squared, take away B squared, and that will give me what A squared is. So we would use the take away version. So if I know both of these straight sides and don't know the hypotenuse, I use the add version. If I know the hypotenuse, I use the take away version. So I want you quickly, which version would I use for these questions? A, B, C, and D. Quickly let me know. Pause the video, have a go. Right, I know the hypotenuse, I must use the takeaway version. I don't know the hypotenuse, I must use the add version. I don't know the hypotenuse, I must use the add version. And I know the hypotenuse, I must use the takeaway version. The next thing that we look at quickly is what is the distance from A to D? How do I get from A to D? So I don't know, but I'm recognizing that's a hypotenuse because I've just done Pythagoras. This length I count 1, 2, 3, and this length I count 1, 2, 3, 4, 5. So I can now do A squared plus B squared equals hypotenuse squared. I'm just doing it on a grid instead of being told the numbers. So I just type in 3 squared, add 5 squared, and press equals. I'm just going to do that. You do that as well. 3 squared, add 5 squared equals 34. So I have to, remember, square root the answer, and I end up getting 5.83. 5.8 will do to 1 decimal place. Let's do one more. So find the length from M to N. You have to know to make it into a right-angled triangle. That's the only way we're going to be able to do this. Count these, it's 6. Count along here, it's 7. So we must do 6 squared, add 7 squared equals, then square root whatever that answer is. So I'm just going to type it in again. 6 squared, add 7 squared equals 85. Square root of 85 is 9.21. So 9.2 to 1 decimal place. The last part is you may have to find the hidden right-angled triangle. So this is an exam question. Where can you possibly see a right-angled triangle? I see it's here. I don't know the hypotenuse. I do know this length. It's the same as this 5, so I put 5 here. Now I don't know at the moment this little one, but these numbers are going to help me. 9 all the way across, 7 all the way across to there. 7 add 2 makes 9, so this one must be 2. So I've found my right-angled triangle to do the Pythagoras. Have another look. Where is Pythagoras hidden? It's hidden in plain sight here. 20, 30, and my hypotenuse. So I would be doing 20 squared add 30 squared equals square root your answer to find this. This question actually said find the lengths of everything. So you had 20, 30, 20 up there again, 30, and 2 hypotenuses going either way. Right, last question, I'm going to ask you to have a go at this one. It's tricky. This was an exam question. It says, work out the perimeter of triangle ABC. A to B to C. I'll give you a little clue. I'm hoping you've spotted a right-angled triangle. So that's how you can work out this mini hypotenuse. Ooh. I'm hoping you've noticed the other right-angled triangle, 5 and 14, to work out this hypotenuse. And the last one is this one, isn't it? We don't know this length and we don't know this length yet. But look, if it's 14 all the way across and 8 up to there, you can do 14 take away 8 and you know it's 6. And 9 all the way down, and this is 5, so it must be 4. And now you can work out this hypotenuse. And then you can work out the perimeter of everything. See if you can have a go. Pause the video. Right, your answers are here. We've got this hypotenuse of 12.04. This hypotenuse here is 14.866. This one was 7.211. I added all of those numbers up and got 34.1. So what are the main points of Pythagoras? If you know A and B, you have to use A squared plus B squared, and that equals the hypotenuse squared. If you know the diagonal, if you know the hypotenuse, you have to do hypotenuse squared, take away the B squared, and that gives you the A squared. Hopefully you now understand a bit more about how to do Pythagoras' theorem to find different missing lengths.